joins, then they can join. Basically, I met Phil at the developers conference like a few years back, and I had a funny story. He did a presentation on remote working. I came to my job. I present that. I actually emailed him. He sent me the slide. I present that to my boss. He led me for a little bit, a few days remote, a few days home, and then COVID came, and everyone is remote now everywhere. So that's a really good segue because that tells me that the community, when you actually come to these events like that, is like you cannot be strong by yourself. Like you can learn a lot. You can have someone here, and then you can ask questions to Phil. You can email him later. You can do a lot of things. Now, the topic of today, I'm really excited. We had a meetup last month with Michael Washington, and he talked us all the way through saying setting up your model, actually saying setting up your Azure OpenAI resource on Azure until all the place to do your own embeddings, vectorizing, ask your questions to the model, and so on. We are, Jose and myself, are working right now in a carbon credit AI product. Basically, we're trying to forecast how much carbon credit certain amount of land has. And we're doing that through AI. So I'm really excited to see practical application of AI right now everywhere. I think that everyone who doesn't get in the train of AI nowadays is gonna get behind because there is so much that you can do. I'm pretty sure that everyone knows Fields, but I have looked up to him for a long time, so I'm really excited to be here to see the talk and to ask my own questions after the presentation. So with that one, I will not go more in depth. I will let him do the presentation and we'll go from there.
Uh, Step one is to turn on the. Oh, I see. Yeah. Oh, I see. But now I hope it's visible. I don't see the display.
See? Maybe was here because was not totally.
Oh, yeah, there it is. Okay.
Near photo color, I think.
Is it? Oh, it's weird. Okay, great. And then let's see.
No, no.
So I'm mirroring now, but I want to see my, let's see, reverse cycle. Oh gosh. So what what I haven't yet figured out, and I need to practice this, is in PowerPoint. Anyone here know Keynote well? In PowerPoint, I would just do the play and it would do the right thing. So here it's not showing me my speaker notes. So it looks like I have to extend. So use that extended display.
I'm going to the same program. Usually I will look like that. Everything works.
I don't know. Closing main display, extended display. Okay. So the problem will become when I'm doing demo that keeps switching in. So I need to find a solution for that. So I apologize in advance. So recent advances in generative AI like Stable Diffusion, Midjourney, ChatGPT has the industry more hyped than a caffeine-addled toddler, right? And it may leave you asking questions like, is this hype warranted? Is the singularity near? How do I leverage it in my application? So we're going to find out. I'll talk about it, and in particular, we're going to look at these three things. I'll give you some definitions of terms. We'll talk about some examples of what prompt engineering is, and then I'll get into application development. The application is something I wrote that is mostly ASP.NET core based, but a lot of the things I do would apply equally to cross-platform, mobile development, and so on. But first, a little bit about my favorite subject, me. So my name is Haack, and I know what you're thinking, what a great name for a programmer, Phil. And I'm on Threads, and I'm on Twitter, and I keep a blog. And I got my first computer when I was around 5 or 6. It's TRS-80. Anyone here ever seen one of these? No. I know in this photo I look old for my age. But I've been in love with computers ever since. And I'm most well known for NuGet, ASP.NET MVC, and GitHub. And I wouldn't say I'm an expert in AI or natural language processing, but I've been building applications with it for a while now. And for the past couple of years, and at a company called The Serious Business, which unfortunately I just shut down. So in the back there's Paul, who's my co-founder. We gave it a good try, it didn't work out, and so now I just go around giving talks about what we learned. To get started, I want to define some terms so we're all on the same page. For example, what exactly is AI? It's magic. So AI, or artificial intelligence, is a machine capable of performing tasks that typically require human intelligence, right? So this includes things like categorization, image recognition, natural language understanding, image generation. All these things used to require humans to do them, and now computers are getting better and better at doing it. AGI, so I want to distinguish between AI and AGI. So AGI is artificial general intelligence, and that's AI designed to learn, think, and perform at human levels or above, right? And this is the kind of AI that can reason for itself, take on any sort of task except opening the pod bay doors, and the kind of AI that's often depicted in movies, but it's the kind of AI that doesn't, as far as we know yet, exist. What I'll be talking about is Gen AI, or generative AI. And this is the kind that, this is AI capable of generating text, images, or other media using what we call generative models. So AGI should not be confused with this type of AI. Tools such as GPT, Midjourney fall in this category. And generative models are basically fed large data sets and programmed to learn patterns in that data and then recreate those patterns, right? It mimics those patterns to create new content. So basically, generative AI is monkey see, monkey do. So this data-driven mimicry is a key aspect in this current generation of AI technology. So for this talk, I'll focus specifically on LLMs, or large language models. This is a deep learning algorithm that can perform a variety of natural language processing tasks. And in particular, I'm going to be covering GPT by OpenAI. This is what I have the most experience with. There's a lot of other technologies now, right? There's Claude, there's OpenGPT from Azure, there's I'm blanking on the name, but this is a language prediction model that uses machine learning to produce human-like text. And there's a couple key terms here I highlighted: prediction and human-like. This is your clue that this is not general artificial intelligence, right? The results of using GPT can appear like it's, can be kind of uncanny. It almost feels like it really is thinking. But it's not actually engaged in reasoning to produce its results. So how does GPT work? Well, it's 3 steps: like, understand, question mark, and then a problem, right? So I have this schematic of how it works. I'll kind of walk you through it. So the first thing we're going to look at is you start with the prompt. The prompt is an instruction to GPT. It goes through the tokenizer, and then the tokenizer will break that prompt into token. And I want to walk through an example of this by going to this site called the GPT tokenizer. This is where escape. So unfortunately, you can't see that unless I go here, and then I can't see it. So I'm going to have to switch mirror. So I used to be a Windows person, then I became a Mac person. This is one area where Windows is so much better, is the presentation stuff. Or I just don't know. So here we have an example of a tokenizer, right? So I'm just going to write something like prompt engineering is fun and prompt text and prompt. Okay. It doesn't make any sense, but there's a couple things I wanted to show you here, right? Is you can see here how it's breaking up how it's breaking up these things into tokens, right? So these numbers here represent the token for prompt. In the middle of the sentence, notice there's each one of these has a space in front of it. This initial prompt, it broke up into 2 tokens and so on. It's not too important to understand that. Like I just kind of pointed out to, like when you're feeding a large language model, ultimately you're just feeding an array of numbers, right? And it's really interesting to me, for example, that it distinguishes between capital prompt and lowercase prompt, so that when it and the spaces are there so that when it puts these tokens back together in a new sentence, like it doesn't have to worry about like inserting spaces in all the right places. They're already there in the tokens. So that's just a small array. Let me go back to. Use as okay, good. So play from here. So the other thing to note is that after it tokenizes it, it will create an encoding into a giant matrix of numbers here. And so what that's doing is taking each token and its relative position and encoding all this information about each token. And in fact, in GPT, the case of GPT-3, every token is represented by a vector of 768 numbers. So you get this giant matrix, and you pass it into the system, and it decodes it, and we'll talk about what that is, and then it produces a result, right? So this that matrix includes and what you might have heard the term embeddings. So it's the embeddings, positional encoding, and attention. All these terms are like I won't go too deep into these terms because I'll be honest, like unless you're doing studying LLMs like deeply, it's really difficult to understand exactly what these mean. What I understand them to mean is these are just enough information for it to generate text that looks like the text. So let's get into it. So first we start with this giant encoded vectors embeddings, right? So at this point, this is a fairly mechanical process where it takes your prompt, takes it, sends it to the language model, and then it attaches a probability distribution and produces the next token. So for example, let's say you type the prompt, once upon a time not long ago. So that gets fed to the language model, and now we have this probability distribution. So given this matrix, this encoding of this is the probability distribution of what the next token is. Okay? And so you can see like A is 0.015 all the way down to Zux, which is 0.01. And it basically just rolls the dice and says, okay, what should be the next word? And let's say, produces when. Now, there's a thing called temperature. So you can set the temperature to 0 in GPT, and that means it will always pick the most likely word. And what that does is, you always get the same, given the same input prompt, you always get the same output. And it turns out by adding a little probability, you get better results. You get more interesting results, which is why they have this probability distribution. So where does this probability distribution come from? That's where all the training happens. So when you hear like, oh, we're currently training GPT-5, that means they're like feeding it tons and tons of data and looking at every possible sequence of words and looking at what's the most likely next word and entering it into this probability distribution so that when they generate, tokens, they have this model. So here's the thing that's interesting that a lot of people don't realize when you're using GPT is, you feed it a prompt and it generates all this text. But under the hood, it's only generating a single token at a time. So, in this case, we rolled the dice, we got the token win. Now, that means that onto your existing token, so basically adds this giant, matrix, and then it passes it back through the language model, and then goes to the probability distribution. And here we see a new distribution, right? Because this initial prompt is different now. And then it picks people, and then it passes that in, and then it goes again through war. Does anyone want to guess the next word? Okay, nobody here knows this lyric, right? Pajamas, right? So, what are some? The reason why that's important to know is if you ever use GPT and you see oh, there's a token limit of 2096 or 4096, and you notice that it doesn't distinguish between input and output. That's because as far as GPT is concerned, the prompt and the output, they're the same thing, right? It's just adding every one token at a time as it generates it until it hits a stop token or until it runs out of tokens. So your initial prompt is just being appended to and then sent back through the system. So what are use cases of GPT, right? Summarization, classification, translation, text generation / completion, question answering, and many others. So GPT is very strong at generating human-like text, but it stumbles over facts and can be inconsistent. So one of the things people are concerned about it is because it can produce human-like text, but doesn't know how to check facts, it can be used in disinformation campaigns. People are worried about it replacing human reviewers or humans. But let's take a quick look at this in action, right? So I'm just going to go to the website. I really need to figure this out at some point. So I gave this talk, a version of this talk. I keep improving this talk every time I give it. I gave it this version of this talk in Porto and Portugal, and I just ran into this problem there too. I just couldn't figure it out, and I don't have an easy way to. I don't have a projector at home, so I don't have an easy way to practice this. So what was it? Okay, let's go to ChatGPT. And so I'm gonna. Can you all see that? Yep. Okay. Let me hide this. I got you. So let's see. So here I'm telling it to write a Wikipedia article about Phil Haack, who worked at Microsoft and GitHub. We don't need the question mark. So that's my prompt, and now you see that it's generating words. Okay. I love doing this because some of this is very good, right? So this part, yeah, that's true. Significant contributions to the field of technology, that may be exaggeration. But all that first paragraph is actually very good, right? At least I like it. But this part here, I was not born in '79. I wasn't born in Fullerton. I have no idea where it got that information. Cal State Fullerton, I've never been there. I went to college at Occidental. I was in California. His professional journey gained momentum when he joined Microsoft. That actually is true. That's really funny. But so a lot of this feels accurate, and a lot of this is true. But there's some key facts here that it just kind of gets wrong. Because if it doesn't know, it's just going to make it up. Because what is it doing? It's just looking at generating the next token, right? It doesn't know how to actually think or reason. Let's do another example I like is asking it a math question. So what is 32,412 times 93,823, right? So is that correct? Let's see. Here's the real answer, and here's the answer it gave, right? And no matter how I try to tell, like, show your work, it always gets this wrong, right? And the reason is I picked two numbers that are probably nowhere in its data set. And what it's doing is it's saying, well, I'm going to produce a number, you're probably looking for a large number in the 3 million range given these two numbers, so I'm just going to generate some number. And great. I'll show you how to fix this actually a little later. So let's get into prompt engineering. So I find it fun to show how it's wrong, but then, it wouldn't be a great talk for practical application development if I stopped there, right? So we're going to look into what it's strong at and how to. That's cool. No. So let's cover prompt engineering for a bit. So this topic could be a talk in its own right. I'm just going to cover some key points because we don't want to be here all day. So prompt engineering. This is the art of giving an AI instructions in order to coax a useful result. And I use the word coax intentionally because it's not like programming where if you have a specific input, you know the output that's going to come out. This is probabilistic, right? It's getting it to produce the output you want. It's a lot like making wishes to a genie. You have to be very intentional, careful about what you say to a genie because they'll do exactly what you tell them, and it may not be the right thing, right? So prompt, as I mentioned before, this is natural language text sent to or received from an AI. And I mentioned that received because it's usually added back on and then sent back in, right? So in GPT, there are roles for prompts. You have the system prompt. And when you use ChatGPT, like the website, you don't usually see this stuff, but you will see it in the playground or if you use the APIs. So you have the system prompt, right? This sets the overall context for the prompt typically used to configure your AI in some way. So for example, a fun one for a system prompt is say you are a pirate of the seven seas, and you can have it talk like a pirate the entire time. Now, user is like, the supplies the question or command to the AI, right? So translate this text into Klingon as an example user. And then the assistant responds to the prompt, with Klingon. And these roles are important to leverage when you're using GPT. So some prompting best practices. First, start simple and iterate. I think that goes for any kind of software development, right? But it really is an iterative process. A lot of times people are like, oh, I need to cover every base, so I'm going to write this really long prompt, and they don't get good results. So you start simple and then try things and see what sticks, what doesn't. You want to be direct and specific. You can get good results when you specify tone, length, style, format, audience, scenario, all these things. And I know, like, some cultures, it's not considered polite to be direct, right? Like, people will ask questions in a very roundabout way. Oh, would you kindly please, blah, blah, blah. And, since it's not actually thinking, it's not going to be offended if you're very direct, and you'll get better results. Put the instruction first. So start the user prompt with the main request, the main question, the main command, and then add context after that. And then provide context, all the necessary context that you're going to help you get a good answer. And provide examples. Providing examples is probably one of the most powerful things you can do. And you can provide examples as both user and assistant. And I'll show you what that means in a second. Experiment. Word choice, ordering, personas. So persona would be like, imagine you tell the AI, like, you are a world-class archaeologist who likes to dig up old treasures, and then and then ask a question about archaeology. Sometimes you get better results than if you just ask the question. Experiment accordingly. So some more tips. Be positive. So Nike was on the right track when they said just do it. Tell them to prompt what not to do and leave them to do just that. So if I told you don't think about purple elephants flying around here, like the first thought in your mind is purple elephants flying around, right? And LLMs are the same way. Like if you tell it, don't respond with anything about Disney characters. You've introduced the concept of a Disney character there. So what is the most likely next token? A Disney character, right? So instead of telling it what not to do, telling it what to do, and like only respond with Marvel characters, for example. Hopefully, it won't respond with Disney characters in that case, right? Give the model an out. So it's often very useful to say, tell the model it's okay to say I don't know if you don't know, or don't respond if you don't. Well, actually, don't see the thing. It's okay to say I don't know if you don't know, and that's a helpful way to reduce hallucinations. So hallucinations is when it just generates like the fact like I was born in '79 in Fullerton. That's a hallucination, right? It just basically made stuff up because it didn't know. Break complex tasks into subtasks. So, for example, if you wanted the AI to write an essay for you, rather than just say write an essay, you might say write 3 statements for this position, against this position, and then summarize it in an essay. And you can often get good results that way. Ask for its chain of thought. So, chain of thought is a really powerful technique to ask. You ask it to explain your reasoning. Like you might say in a list of bullet points, how did you come to that conclusion? And then I've been noticing sometimes when I use GPT-4, it'll do this automatically, and sometimes it doesn't. I don't know why. Check the model's comprehension. So like you give it a command and say, do you understand the task? And it's an interesting technique. And sometimes it works well, sometimes it doesn't. So, oh. Yeah, so like, be this guy. Are you sure about that? I forgot that I did have audio in this class. All right. So my biggest tip is use the playground. So this is platform.openai.com/playground, and we're going to. I'm going to switch to this and show some examples. So. I feel like I'm getting a little bit better at this switching. It's not too bad. Platformai.com/playground. Log in. Alright, so we're going to go to chat playground. So can you all see that okay? I'll zoom in a little. Okay. So here I mentioned the system prompt. So let's just start with a simple user prompt. AI does this. So here it says, Andreas passes the ball to Joao. Oh, whoops. I have these shortcuts so that I don't have to remember all this stuff, but that's weird. Let me try it one more time. Okay. So Andreas passes the ball to Joao. Okay, there we go. Joao dummies the ball and it goes to Lewandowski, who scores a goal. Who gets the assist? So we're going to submit that and see if it gets the. So this is actually correct. Sometimes it gives me the wrong answer, and my whole demo is, about how to improve the result. But let's pretend it didn't give me the right result. Referee. So now what we're going to do is we're going to give it a system prompt. So the idea here is that we want to help it produce better results. So we're telling it, you are a world-class soccer referee. So then I mentioned personas earlier. Please provide an answer and reasoning in JSON format. So the reasoning is like part of the chain of thought idea, right? And then I'm going to just delete this again, and we'll ask the same question. Submit. And here we get assist, Andreas. So that's pretty good, but I want to give it an example. Like that's not exactly, let's say that's not how I want the response, right? Because that, I can't use that as that format in a program. I kind of want it to be like question answer. So I'll do AI example. So here I'm going to give it an example. And you notice here I use these triple ticks to mark this as an example. A lot of people will use triple quotes as well. I think both are kind of effective, but the idea here is I want to make it clear that this part is the example and not anything that comes after it. In this case, I don't have anything after it. But I'm just going to delete this and then submit the same question again. And here we get a format that I could actually use programmatically, right? Answer Andreas, reasoning. Andreas gets the assist because he directly passes the ball to Joao, who then dummies the ball, allowing Lewandowski to score a goal. What is really amazing is that sometimes I'll get this to answer that it's Joao, but right now it's telling Andreas because this is, if you don't know soccer that well, this is a tricky question, and and the fact that it gets this correct kind of blows my mind. Because I think a lot of humans will get this wrong. So the final thing is, if I was building this prompt in an API, I might actually seed it with an existing user and an existing assistant answer as yet another example, so that, and then programmatically I would add the user question in the next user block. So for example, AI offsides. Oh, I don't have that one. Okay. Can a person be offsides in their own half? So let's submit that. All right, so that's pretty good. No. So the key thing here I wanted to explain is I think it's good for formatting and that kind of thing to show an example in the system prompt. But for even better results, have an example of something that's a realistic user and assistant response, and then programmatically throw your questions here, and you'll get really good results. And sometimes, some people try to resort to training right away, but sometimes if you store a few examples of user assistant response and make them part of the prompt, uh, you get really good results that way. All right, so let's go back to Keynote. Okay, so I'm going to give a demo of an app. Oh, actually, so yeah. And so in this app, I'm using, OpenAI, as I mentioned, the APIs. In particular, I'm using the azure.ai.openai library. So this is a client library written by Microsoft that can work both against Azure OpenAI as well as OpenAI directly, specifically GPT. So this app I'm going to show is built on ASP.NET Core, as I mentioned. I use the EF Core, SignalR, Tailwind, React, Refit. Oh, and I just recently added Blazor, so I forgot to add that to this list. And most of the documentation is for the APIs are here. Let's play around with it. Okay, so. There we go. I'll show you the app running. So what I did there is I have a command that runs like ngrok, Postgres, all that other stuff, and then but I excluded the web side, and I just run the web directly from Writer. Wait, what happened to my? this is a demonstration of using OpenAI to generate text. It's pretty straightforward, right? So we have a system prompt that allow you to edit, and let's change it to a snarky chatbot who's part of the demo I'm giving was representing me in ChatGPT as well. Write a question: how tall is Mount Everest? We'll just do a simple question. Okay, so it's not working because I haven't implemented it yet, right? So let's do this. Go to. Can you see that? Oh, wow, that's really small. That. Okay. May have to go 150. All right. Pages, demos. So, anyone here not familiar with ASP.NET Core? Okay, so everyone here has some experience with ASP.NET? Okay, good, good. So, this is a standard Razor page where I have the form, and here's the code behind. We have the system prompt defined here, and then here's where I'm building out the prompt, right? So bar options equals chat complete, options messages equals, here's the system prompt, and then I send that, I get a completion. And what are we missing here? We're missing the user prompt, right? So let's do that. We'll just add it here. New chat message, chat role dot user, and what is it? Question. So if what we saw in the playground where we had the roles, so we're just populating that. We'll send it to get chat completion, and then we'll post it. We'll post the response. If we get a value, we return the answer, and if not, we say I don't know. So I will restart that. Pretty straightforward. So chat completions, is interesting because that's calling what is called the completions API, and you think of it as like, oh, you send it a prompt and it's just going to complete it by adding more tokens to the end, right? So I'm going to submit this again. Okay, I find the snarking really annoying. You are a succinct chatbot, so let's try again. Okay, so we are going to ask, much better, right? So, as you can see, personas are very important. So we said, how tall is Mount Everest? And it said Mount Everest is approximately 8,848 meters tall. But we're here in America, we don't talk meters. So let's ask, how tall is that in feet? I almost said it in American, but okay. So you notice here it says, well, without additional context, I'm unable to provide a conversion in feet. Can you please clarify what needs to be converted? So one of the other things that I didn't realize when I first started using GPT is I expected it to work like the website. And if the website maintains context, right? Like you ask a question and you ask another question, it actually remembers what you said earlier. The API, excuse me, I think I just hit puberty. The API doesn't remember anything for you. So if you want to maintain state, you have to maintain it yourself by continuing to add it to these messages. So we're going to implement that. So I'm going to add the previous messages property. So public string previous messages. And I'm going to do it in a kind of a dumb way right now. So bind property And then we're going to add a hidden input. So at the bottom of this form, we're going to basically just input ASP4, previous messages, type equals hidden, value equals at model dot previous messages. Now, I shouldn't need to do that value because we're doing ASP4, but for some reason, it wasn't working, and I didn't feel like figuring it out. So, okay. So we add the hidden input, and now we're going to, after obviously I need to initialize that property because I have not nullable or not nullable enabled. Okay. So let's see. What do we want to do here? So what we're going to do here is add history to the message collection. That would be the final option. So I'm actually going to remove this user role question because what I want to do here is before we send it, we'll add add user. Wait, did I do that? Oh, new chat message. There we go. I probably should let, I have Copilot going, I should just let it do it. There we go. Thank you, Copilot. Now, that's close. So I'm cheating a little bit. I have this, what I'm gonna do is in that hidden input, I'm gonna take the history of questions and answers, and I'm gonna throw them, I'm gonna serialize it into previous messages. So what this code is doing here is deserializing previous messages and then adding them to the messages collection. And then I'm going to add the new question here. And then before we return the page, I need to update previous messages and serialize things, right? So you see here, previous messages is up. I'm going to take the existing set of messages. I'm going to skip the system message. We don't need to store that because that doesn't change every time. And then I'm going to put it in JSON, put it into previous messages. So now when I run this, I wish this was faster. What I was complaining to David Fowler, like one of the things I really dislike about ASP.NET Core and ASP.NET in general is how slow the development loop is because of all the compilation, and that there ought to be an interpretive mode. Now that I don't work there anymore, like I get to complain. All right, so let's do the same thing before. How tall is Mount Everest? I'm gonna submit that. Come on, did I get submitted? Oh.
What did Fowler say?
I'm like, yeah. Did I do something wrong? Oh, I added this question twice. Let me try again. Let's see, what did I do wrong? I don't want to. How tall is Mount Everest? This is one of those risks of doing live coding, right? Is something goes wrong. But you know what? Let's debug it together. That's always fun. Maybe we'll learn something. One last time. How tall is Mount Everest? Oh, it's not even submitting the form. It shouldn't matter where that is. One last try. Can't get this time. Looks like what's happening is it's not submitting the form, and I don't know why that would be. That's kind of stop. Let's try it. Alright, so I have a hidden input. Why did this change? Oh, shoot. I don't recall changing that, but see, this is the danger AI. I think it made a change on my behalf that wasn't correct, and I blame Copilot. Yeah, it's never my fault. It's all Copilot. Let's try this one last time. All right, ask the AI, how tall is Mount Everest? That really didn't submit it. Oh, I bet I know what it is. So because previous messages is not nullable, it becomes required even though I don't have the required attribute on it. So let's just make that nullable, and I bet this is gonna work. Okay, that was that's all. Yeah. Come on. Ah, here we go. Okay. All right. Okay. How tall is that? Okay, so what just happened is I just asked, how tall is Mount Everest? It gave it in meters and feet this time. See, it's messing with me. How tall is that in miles? Or yards? Let's do yards. 32,667.9 yards tall. That can't be right. That is absolutely wrong. Okay, that is interesting, but the key point there is what I want to show you is how to maintain state, right? Like it's up to you to maintain state. Now, here's the thing. I'm just, I can ask, okay, that is not correct. Let's submit more. Yes. I apologize for the mistake. It's approximately 29,000 feet. That would be about 9,677.2 yards. Much more correct, right? I don't know if that's exactly correct. One of the key things you'll note, though, is I just keep adding, in order to maintain state, I'm just adding these messages into the next API call. At some point, I'm going to run out of tokens if I let this conversation go on too long. And one of the things that's tricky is, like, at some point, if let's say you're building a chat monitoring app and you need to send the whole state, at some point you're going to have to truncate the beginning of it, the message yourself, or summarize the state of the conversation and then make that a single entry, because you'll hit the token limit. And also, tokens cost money. Every token is some fraction of a cent. So if you are sending way more tokens than you need to, it's going to cost money. I will show you something a little later that kind of does some of that for you in a specific scenario. But let's move on to oh yeah, functions. Okay, so this is the completions API. I just showed you that earlier. But we're going to do something with live data, so using GPT functions. So one of the challenges, right, I can ask questions to GPT of what is already trained on. But what if you wanted to have answer questions based on data in your databases that you do not want to feed to OpenAI? Like, how do you give it access to that without, like training a model or without, you know, posting all of it to the public GPT? This is where GPT functions comes in. So what you can do is you can describe functions and have the model intelligently choose to output a JSON object containing arguments to call those functions. So it looks something like this. So here's a function we'll write. It's called arithmetic, and you give it this JSON as part of your prompt, and it says description. It performs arithmetic operations, and then you describe the parameters. And so in this case, we have 3 parameters: left, operation, right, and then you describe which of those parameters are required. So left, op, right. And with that, we can actually write a function to multiply 2 numbers and teach GPT how to do it correctly. So I'm gonna show an example of this. So let's go to library, we've got functions, and I'm gonna create a new one called, let's call it arithmetic. And I think this is one you don't want to watch me type out, so I'm gonna just do functions. Why is that not working? Oh my gosh. Yeah, functions. Oh boy. You know what? Nobody wants to see me live code because it's problematic. So I'm going to switch git. Forget this. So this is like the Julia, I don't know if anyone knows Julia Child's moment where she just like pulls out the fully baked turkey. So I'm switching to my main branch, which has everything already implemented. So you don't have to watch me stumble around trying to write code. So where's the arithmetic? So I have this arithmetic function. Do arithmetic, right? It takes in arithmetic arguments. So this is just I just defined these record types, like left, operation, right, and then answer. And I just wrote a simple method. Where it gets interesting is so if you recall, this is earlier where I had the response from get chat completions. Oh, here we go. So here's where I was creating that options thing, and here's where we have the the system net prompt. But now I have this new collection I'm passing, which is a list of function definitions, right? And here you can see I'm just basically what I showed earlier. I'm just re-implementing that in C#, right? Arithmetic. Perform simple. This here is a prompt. So the description is a prompt that is used to determine whether this function should be called or not. So you want to be, you want to be very intentional about this description. So if when you submit a user prompt, if it matches the description of a function, instead of responding directly to your prompt, it will respond with some JSON that says, "Oh, you need to call this function." So here's, this is just the same thing I showed before: left, operation right. Each of these descriptions is also a prompt that explains what goes in there. And then what happens is when we get the answer, if the answer is a function call named arithmetic, we're going to call this, we're going to actually call our function. So it's on us. Like, all it's going to do is say, yeah, you need to call this function based on this prompt. We have to call the function. And then what's interesting is we take the result of calling that function and we pass it back into GPT. You see here, I have a new chat message role function, and I have the results as JSON. I pass that back into GPT, and then it's going to take that result and give me a proper answer. So let's see this in action. Let's see. What is? Oh, that's yeah. That's multiply. Is that it? Yeah, done. There we go. Okay, so I don't know if you recall, but that is the correct answer now, right? So now we've taught GPT how to multiply. Let's go through the code and we'll see kind of what that looks like, right? So we'll stop. Put a breakpoint here. Bye. Oh. We're going to look at options, messages, results, chat message. Okay, so there's our user message. What is, the multiplication? What's more interesting is the result when we get the response. So we wait while chat. Okay, we get the response, and in the value, completions, choices, kind of zoom in here, look at the message, and we'll see that it's a function call, and this is what it looks like. Can you all see that? Okay, so it so it's telling us that these are the arguments to the function call. So it figured out that the left is this, the operations multiply, the right is this, and then the name of the function is arithmetic. Now we take that. This is a list pattern matching. It's a little complicated, but basically it's saying, oh, if there's a value with a single choice that has a message property with the function call dot name property of arithmetic, then call this method, right? So we'll jump into here. So we grab the function call, we grab the arguments, and we deserialize them, and then now we have the arguments in code, left, multiply, right, and then here's where we do we do arithmetic. One thing computers are really good at. And then we add the message that this is the function call message, right? We want to add that to our options because we want to maintain that state. But then we also want to serialize the arguments with the answer, and then add that as a message with the function.
idea is that you just inherit from this chat function. You have a name description, and you have a type for the arguments, and then I just automatically do this for you. So one of the classic examples in the OpenAI's, what do you call it, the documentation is the weather function, right? So get current weather. So rather than doing all that rigmarole, if you use this, you can just like write a weather function that inherits chat function. You just have a type for the weather argument and a type for the result. If you go to this, you can see here, I just said, oh, location. I have a description property, the property name, and whether it's required. And then same for the unit, Fahrenheit. And then I have a type for the result. And then all I have to do is invoke async. And here I get the arguments, right? That was produced by OpenAI or GPT. I call this weather API, and then I get the result, and I just return this result. And all that other stuff about feeding it back in and all that, I do that automatically for you. So let's try this out. We'll do this in a So this is a different part of the app. This is a React app that's a chat room. So hey there, kind of standard chat room. If you were to go into bit.ly/hack-AI, you could actually chat with me here. But when I want the bot to do something, I'll say, hey bot, what is the temperature in Phoenix, AZ? So hey bot is kind of my way of saying, okay, I actually want GPT to respond. Now, one thing I did here is I wanted to be able to see what the bot is doing and thinking. So I wrote, there's a whole API for console messages in Chrome. So I posted the log to the console. So you can see here, like that first message didn't address me. So the message addressed me, I'll try to respond. I have a function that can help with this. I'll call get current weather, location, Phoenix AZ. So now we're just waiting on it to respond back with the actual weather. For some reason, it's taking a long time. That may be GPT.
So how does he know they have to call the function? For example, the arithmetic, the one before and this one.
Okay, so if you recall when I was doing it's a great question. So before we define this list of functions, do you recall this? This list of functions?
Yeah.
So I wrote a framework so that I would automatically generate these function definitions based off the types in chat functions. So here I wrote a weather function, and the description is get the weather, current weather in a given location. So it's gonna populate the function definition and use that as prompt. So when a user prompt matches this prompt, it will say, So in this case, now I've parsed these arguments for, or I didn't parse it. OpenAI parsed these arguments, gave it to me. I'm calling a third-party service trying to get the weather, and I need probably better error handling. All right, let's try something else. So I have a different function where I also wanted to be able to store and retrieve information about people in chat. So like, the idea was like, oh, maybe we wanted a bot that can kind of listen into conversations and then recall things for you, right? So, hey bot, I am giving a talk in Arizona. So this is calling a function. So here's, okay, that's not right. Let's see. I have this function, store user fact function. And basically what it's doing is like, stores information about a user when a user says a fact about themselves. So let's try something that's more factual. Hey bot, I am 5 feet 9 inches tall. Okay, got it. Now I can ask it, how tall am I? Hey bot,
How tall am I? I think I'm going to change this demo to just always go to GPT. Oh, you're 5'9". Now, here's the interesting part, right? So I had this other function called retrieve user fact. And so it was able to parse out, oh, the user is Haack. They're asking, how tall am I? And I've added this justification because asking for justification is really helpful when you're debugging things later. So users asking for information previously mentioned. Now here's the thing, how do I get that information out of the database, right? Because like it told me the question is how tall am I, but I've just stored, what have I stored in the database, right? I'll show you. I've stored, user, I am 5'9" tall, the source and the justification, right? So remember I mentioned embeddings before, like how when you have a prompt, like it creates an embedding. Well, what I'm storing here is, let's zoom in on that. Every time I store this fact, I store the embedding for the fact. So this is like that giant ass array of tokens that represents that fact. That's all look at how big that is, right? Woo! All right, let me show you what that looks like in code. So embeddings are really powerful anytime you want to do any kind of searching of information. Let's store user fact function. Okay. So here I have this function called get embedding. So when you say a fact about yourself, it parses out, oh, here's the question, here's the username, but I still need to create an embedding, and this is just calling the get embeddings async API. And that is going to return this an array of floats, and then I store it as a vector. So I'm actually using Postgres, and I'm using the PG vector plugin. So when I first gave this demo, I actually just stored it as an array, and then I did the cosine similarity thing myself. So when you think of a vector, if you remember like math, vector is like let's say an arrow in space, right? 3D vector. And so what we want to do here is when we ask a question and we're trying to find a vector that's very close to it, we're doing a cosine similarity. So like if it's like this and your question's like that, that's not very similar. If it's like that, it's very very far away, and it's almost like the opposite. But if they're narrow, then it means that they're very related, right? So like if we're actually calculating that sort of like the where they're both pointed at, these two vectors. So let me show you retrieve. And so I actually had GPT write the cosine similarity function, but that was really inefficient because I'd have to take every fact out, calculate this cosine similarities, and find out which one's most similar. But with PG vector, this is really cool. So I have this user facts table, and then where the username is the username, and then I get the cosine distance, f dot embeddings, cosine distance embeddings. So this is like a built-in NPG SQL. NPG SQL, if you're not familiar, is just how you connect EF core to Postgres. And so that is going to convert that into a vector calculation on the database. And then I say, well, where the distance is less than or equal to 0.25, and then order by distance. And so this is sort of like an arbitrary thing. That's like saying, oh, if it's 75% similar, I want it as one of the results. And then if the fact count is greater than 0, join them all up, right? So for example, I can be like, let's go back to the chat. Hey bot, where do I live? And I've already told it this before, and it's not in memory because since we started it, you live in Bellevue, Washington. Now, where it gets really cool is, hey bot, okay, let me refresh so it clears the state. Hey bot, what is the temperature where I live? Now, this might not work because it looks like the weather service is down. But what's really interesting is what's happening here is, let's look at this. It's like, I have a function that can help with this. Oh, it worked. Let me try that again. Because, and it might be a little hard to follow, but I think it had my location in memory, right? So let's try this. Hey bot, what is the temperature where I live? And what we'll see when we look into the brain of the bot, it's like, okay, the message addressed me. So first of all, it's like, oh, I don't know where you live. So it calls the retrieve user fact function, right? And then it's like, now that it has that information, it's like, oh, I don't know what the weather is, but I know a function that I can call that. And it was really interesting because like when I first started building this, I would call the function and I'd return it, and sometimes I get this weird result. And I realized, oh, sometimes when you pass the result of a function back into the completions API, the result you get is another function call. And then I was like, oh, maybe I'll just throw this in a while loop. And when I did, boom, suddenly this started working, and I was just blown away. Like, now, unfortunately, we're having trouble with the weather service. But the key thing I want to show here is by just looping over, if it's a function call, a function call can result in another function call. And so now I can do these really powerful queries that will leverage multiple function calls to get me an answer. And when I discovered that, I was kind of blown away. So the last thing I want to show, so I showed functions, I showed embeddings. So this is the API for embeddings. And then the assistance API. Okay. So one of the newest things that GPT just came out with is, that's my son. So one of the newest things that assistance came out with, or GPT came out with, is the assistance API. And the idea is that if you want to build an AI assistant with an application that can leverage models and tools and knowledge to respond to user queries, you can use this assistance API and and you can build the next Clippy, right? So the assistance API is a little tricky. So we have these, you have an API to upload files, and you do that independently. So a file will be like a PDF or some content that you want the assistant to work against. Then you create an assistant, and you create a thread. and then you add messages to the thread, and then you run the assistant against that thread, and then you poll for it to get the answer. So it's a little clunky, but when you put it all together, let me show you how it looks. Okay, so I got this assistant thing. So here I've created an assistant already. I could create, if you give me a good, interesting PDF file, I can just create a new assistant. We're gonna run this assistant. I call it Lease Assistant. And so this is, I'm using Blazor here. So I'm like, I uploaded my lease earlier of a new apartment I just moved into. And so now I can ask you questions about it. Hey, or I don't have to say bot here. This is it. Like one of your classic assistant things. May I hang pictures in my apartment? So now we're we created the run, we're polling. If I haven't gotten a response yet in a couple seconds, I throw in this thinking so that, we don't lose interest. If I go into here, we can see that, I keep polling for responses. Oh, there it goes, it just popped in. It says, yes, you may hang pictures in your apartment, but there are some restrictions, yada, yada. And then it also gives you a reference here, a footnote that links directly to the document where it got that, how it generated this answer. So I can ask all kinds of questions like, may I have pets in my apartment? Thinking. It's a little slow, you can see. But, oh, here we go. Pets are not permitted, blah, 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 blah. So the answer's not important, but like the fact that my lease is long, and now that I can ask questions about it and then get the actual reference is great, right? But let's build another assistant. So I now have a factory for creating assistants. All this code is open source and online, so I'll show it to you later. What's the example I was going to use? Oh, so first I have to upload a file, right? So we're going to go to Files. I'm going to upload a file. Yeah, for assistants, choose a file. So I kind of build out all these pages for every single API, and then I put it all together in Assistant. So if you ever play around in this code, you'll see I'll kind of walk you through it. But Uno rules. We're going to build an Uno. Everyone here know what Uno is? It's like card game. I mean, you probably played it as a kid. So let's submit that. So I've created this assistant. I created this file, right? I uploaded the file. Now I'm going to create an assistant. Uno assistant. You are a fun Uno expert who helps people understand the rules of Uno. Oh wait, sorry, that's so you can have a description for yourself, but it means
right? And then we attach this file, Uno rules, and then we'll say we're going to use retrieval. We can add other tools and we can add other functions as well. I haven't built that into mine yet, but you can just have it access to code interpreter, retrieval. Retrieval
is basically, remember all that embeddings and stuff and retrieving? It's doing all that for you automatically. Not only that, when you're adding messages to the thread, it's automatically truncating that for you. So all that logic I would have to write using their normal completions API, they handle it. So I've created this assistant about Uno. So let's go and run the Uno assistant. Hi, I'm the Uno assistant bot. How can I help you? Can you stack a draw 4 on a draw 4? This is one of those things that's very controversial in Uno. And let's see what the Uno system says. stacking a while draw 4 on top of another draw 4, example, blah, 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 is not an official UNO rule. However, stacking is a widespread house rule that many people play by. That is a fantastic answer. So now I have an UNO assistant. I could upload any file and then create a very quick assistant of info on that file. We've got a little bit of time, so I'm just going to kind of briefly look at the code just so you can kind of see. Or actually, even better, I'll show you like, so, you know, under the hood, like, you know, I created this assistant. And then separately, we create a thread. So here are all the threads that are active in my system. Whoops, let's look at this one. And then, you know, for each thread, we have a set of messages attached to the thread. And then when we want to, what's interesting is a thread is isolated. A thread does not have any reference to the assistant. It's when we create what's called a run that we actually, like say, run this assistant against this thread. And then it does the processing, and that's when you do the polling. And you can see that in my code here when I go to, what is it? Assistant, oh, details. Let's see if I can find this code. Here we go. Oh, this is very complicated. So, unfortunately, I'm using. So here, like when you post the message, we create a run, and then that is actually going to raise a message to a message bus. So I have to find that message bus. System hub. Data observer. Oh gosh, where did I put? So confusing. This is the signal R code. Oh, eventing. There it is. Consumers. Chat assistant message consumer. So I don't know if you've ever used mass transit or anything like that, but you know it's a way of changing things to message passing. So here is where I create the run for the thread, and then while the status is not completed, canceled, failed, or expired. And I put a time limit of 1 minute. We get the run and we poll for it. And then if the status is completed, I then have to call again to get the messages and reply with all the new messages. So I pass in, you know, the most recent message that I had created, so that I can get all the messages after that. And so that's how I get only the new responses, because when you call get messages API, it's going to give you the whole thread. So if you look at assistant message consumer.cs, if you ever want to look at this code, you can kind of get a sense of how this is all put together. Unfortunately, it's very complicated in terms of like putting all these APIs together. But once you do, it's pretty straightforward in terms of how it works. But it's not the kind of thing I'd want to write live as a talk, because it just wouldn't be that. One keynote, when you call the assistance API, you have to pass this beta header. And this API is not yet available on Azure GPT, so it's not available in the client library. So if you've ever used refit, I just basically use refit to generate the client. So let me show you that real quick. So I have my own OpenAI client, and I just basically had to model all the types in C#. But what's nice about refit is you just define these methods on an interface. Tell it where to get, what headers to apply, what to pass, and then it generates the implementation for you under the hood, and then you can call that API. So the main thing is mapping like C# isms into what you get. So for example, a thread message, like I have to use the property name a lot because I can't name a property object, and I have a serializer that knows how to take thread ID and then snake case it, or not, underscore snake case it. All right. So here's some key resources that I used to build this talk. So my AI demo, I'll send you the decks to distribute. But so github.com/hack/AI demo has all the source code I demonstrated today. So if I went too fast or something's not clear, you can actually go play with it. And if you want to contribute to it, that's great. I'd love to have a Xamarin app as a front end talking to GPT. I think that'd be really cool. So this article inside GPT goes deeper into text generation and kind of how it works. The observablehq.com tokenizer is really fun to play with to kind of understand how does it do tokenization. The OpenAI playground is essential for we'll spend a lot of time experimenting in there, and then I just take that and throw it in the code. How GPT works, this article by vstolnitz.com. I use that for this as well. pgvector.net is the .net extension for pgvector so that I can use it in C#. And then this article on the OpenAI site about embeddings it's really helpful to kind of understand what our embeddings are and how to use it. So that's it. Thank you. And if you have any questions, I'd love to answer them. Apologize for all the mistakes, but hopefully I got the gist across. So, anyone have any questions? All right. Well, if you do have questions, you're just shy, come up to me afterwards. And I encourage you to check out the source code, log issues, play around with it. Real quickly, how many of you have played with GPT already? Okay. Cool. So how many of you learned something new from this that you hadn't played with yet? Okay, cool. Glad it was. Thanks, Cody. Yeah. All right, thank you very much.